Okay, let's take the function y equals to x squared seen last year. Of course, f of x is equal to x squared. So we want to start moving these functions around. So let's start by making it really simple and taking a point on the graph, 2, 4. Everyone agree with me? 2 squared is 4, of course. Now, remember a few things. A few quotes I'm going to say, those work all the time. You may not know what they mean, but it's good to have them as a foundation. So, let's start with the first one. Y is equal to 4. Now, this is the first video. I'm going to do a lot more introductory videos, but for the moment, I'm going to be explaining a little bit how the videos go in the first couple of videos. So, a lot of the English that I'm going to speak, I'm going to be not writing down. You're going to print the notes or open the notes or however you want to do it. So remember, the function doesn't change. Look at the notes. Look off to the right. That's exactly what the function, the sentence says. So once again, y equals x squared. Our function is f of x equals x squared. F of x and y can be interchanged, however, not exactly equal to each other. One is a variable, one is a function. We'll understand that later. One more time, f of x equals x squared. Let's take the point, 2, 4. Now remember again, y equals 4. In an English sentence, I'm going to read, the function does not change. You do not need to write those English sentences down. They were in your notes. Okay, so now let's take y equals x plus 2 squared. Now, what exactly happened? Well, remember the function f of x equals x squared. Well, what did I do to that? Well, I took x squared and I substituted. I changed x to be x plus 2. Now, most people think if I'm going to put x plus 2 in for x, that shifts it to the right, positive 2 in the right direction. And intuitively, that would seem correct, but most things in math are counterintuitive or not intuitive. So let's see why it is intuitive. So, again, remember, the function does not change. We've taken the point, 2, 4, and y is equal to 4. Remember, y is equal to 4. Do not forget that. So, what would be the new point on the graph? Well, we had the old point, 2, 4. And we're wondering what the new point is. Well, what's the y value? Well, who was listening earlier? Multiple times. It's 4. Another English sentence. The function does not change. The point is 2, 4. So we are asking ourselves, what is this x value that will keep the function 4? Well, we can do this in a multitude of ways. We can use logic. What plus 2 squared is equal to 4? Well, I know that 2 squared is equal to 4. So what do I have to add to 2 to make it say 2 squared? Well, 0. So I know the point is 0, 4. Remember, the function does not change. Y is equal to 4. What squared, what plus 2 all squared is still equal to 4? Well, 0. So the point used to be 2, 4, and now it's 0, 4. Well, what has happened to that point? So let's take a graph. I'm going to shift that down one, and let's take the point 2, 4. 2, 4. Well, what's happened to that point? Well, now it's here at 0, 4. Well, it went left 2. A horizontal translation equaling -2. Left 2. So, originally we may have thought that this caused it to go in the +2 direction. It actually goes -2. Feel free to use a table of values or check my work in the notes, all sorts of extra things. But notice, if we put x plus 2 in for x into the equation, we actually go left 2. A horizontal translation, left 2. Everything about transformations is substituting the opposite operation for the variable. If I want to make my x value change from 2 to 0, or any x value, 2 in the left direction or down, I substitute x plus 2 in for x into the equation. The more and more you do foundational methods that work all the time, rather than little lazy ones that your teacher teach you these little tricks for, until we're much more familiar with the material, always substituting the opposite operation for the variable. So I can take a point and move it left 2 by substituting the opposite operation for the variable. I want to make it x go down 2, so I substitute x plus 2 in for x. Please take a look at the notes for a more thorough description of each and everything I do on each and every one of these pages. I will be going through the rest of the theory much faster, and each and every one of the pages of the notes you will see a video for. Please feel free to try the homework, and if you need further help, please feel free to contact us at NAC Academics. Okay, let's take the function y equals x squared again. And again, let's take the point 2, 4. Now this time, let's keep x as being 2, and let's do something to the function. So let's say y equals x squared minus 2. So most people look at this function and see that someone has decided to put a -2 off to the right. Now that doesn't mean anything to me. This little thing over here, I'm going to teach you how that got there. So again, let's take the function y equals x squared. And now what happened to get that -2 over there? Well, the last section, page of theory, last video, we learned that we always substitute the opposite operation for the variable. So when I wanted to move the graph to the left 2, that means that I want to subtract 2 from all the x values. I substitute the opposite operation, and I substitute x plus 2 into the equation, as seen here. So what if we want to go down 2? Well, we want to go down 2. We want to subtract 2 from all of the y values. Well, what are we going to do? Well, we learned that we want to always substitute the opposite operation for the variable. So if I want to go down 2 and I want to subtract 2 from all the y values, then I do the opposite operation of subtracting 2 from all the y values, and I substitute y plus 2 into the equation. Simply taking y and substituting y plus 2 into the equation. Always substituting the opposite operation for the variable. Substituting the opposite operation for the variable. So again, we have the point 2, 4, and we talked about how x is 2 now. So if x is 2, what does y equal? Well, y simply equals the equation, y plus 2 equals x squared. And everyone's like, what does that mean? And wants to get the negative 2, get the 2 onto the other side. So if we do subtract 2 to both sides of the equations, which I'm rarely ever going to do again for the rest of this series, and if you would like to learn about adding and subtracting, please call us or read some of the notes from the previous grade. So again, we're going to subtract 2 from both sides of the equation, and again, I'm never going to show that step, rarely. So I'm going to subtract 2 from both sides of the equation, and on the right-hand side shows up a negative 2, the same negative 2 we were talking about earlier. So that's where that negative 2 came from. We substituted the opposite operation for the variable, substituting y for y plus 2, and then simply subtracting 2 from both sides of the equation. So we now have our nice and simple equation, y equals x squared minus 2, and we were speaking about when x was 2, so I can simply substitute 2 with brackets, and 2 squared minus 2 is y equals 2. So y is equal to 2. What happened? Exactly what we wanted. We wanted the graph to go down 2. We wanted to subtract 2 from all the y values. So we simply substituted the opposite operation for the variable, substituting y plus 2 in for y, getting exactly what we wanted, getting the point 2, 4 down 2 to 2, 2. Let's see that on a graph. So we had the point 2, 4 again. On the graph, y equals x squared. Obviously, I wanted to make that point go down 2, so I got it down to 2, 2 by substituting the opposite operation for the variable. As you can see in your notes, I've provided a whole bunch more on that. You can see the whole graph of x squared. You can see the exact point moving down. But these are foundations, and I want to start off with very simple concepts, like moving a point up and down, left and right, around a graph by simply substituting the opposite operation for the variable. So if I want to go left 2, I substitute x plus 2 in for x. If I want to go down 2, I substitute y plus 2 in for y. And in the notes, you can see much more detailed English instructions, graphs, all sorts of different notation. The videos are going to be a little bit shorter, more to the point. All right, not again. Y equals x squared, and again we're going to take the same boring point 2, 4 on the graph, x squared. Now let's take y to be 4 again. Remember, y is 4 the whole time. We're not going to talk about how we're keeping y 4 the whole time again. Now let's take the function y equals 2x squared. And what does that do to it? Well, let's ask ourselves, what is x when y is 4? So, what does x have to be? Well, what times 2 all squared is equal to 4? What times 2 all squared is equal to 4? Well, 2 squared is equal to 4. So the only thing that you would multiply 2 by to still be 2 squared is 1. Therefore, x is 1, y is still 4, obviously. So, what happened there? Well, we had the equation y equals x squared, and we decided to change that equation to 2x squared, simply taking x and substituting 2x for it. So, we learned from the last 2 videos on theory, we always substitute the opposite operation for the variable, so it looks like I'm trying to times 2 by x, but that means that I'm trying to times x by 1/2, or divide all the x values by 2. Let's see that on a graph. So let's take the point 2, 4, and we have our new point 1, 4, and what has happened? Well, we used to have an x value of 2, and now we have an x value of 1. So we must have taken the x value and divided it by 2. So again, if I want to divide the x values by 2 or do a horizontal compression equaling 1/2, I simply do the opposite operation and I substitute x4 with 2x, taking the old function y equals x squared and substituting 2x in for x. Again, substituting the opposite operation for the variable. So you can either see an equation like y equals x squared for a question. They might say now we have the function y equals, in brackets, 2x all squared. And they may say what has happened to the graph. And you could say it was a horizontal compression of 1/2, and all of the x values were divided by 2. You might be given a point to transform that point on a graph. You might be given a graph, and as you can see in the notes, again, print the notes or have 2 videos up side by side. Mobile, much better to print the notes. Take a look at the graph of x squared again. Take a look at the graph to the right, y equals 2x all squared. Graph it with a table of values or on your graphing calculator if you're unfamiliar, and you can see we've taken the graph and done a horizontal compression by a factor of 2 or by equaling 1/2. There's going to be all sorts of notation. Horizontal compression equaling 1/2, horizontal compression by a factor of 1/2, horizontal compression equaling 2. Now, this is where it gets ambiguous. Not exactly ambiguous, but for example, let's say that I expanded my height by a factor of 2. Well then, if I'm 6 feet, I'd be 12 feet. Now what if I said I compressed it by a factor of 2? Well, that would mean that I'd be doing exactly the opposite sentence, so you'd assume that I did a compression of 1/2. So again, all sorts of different lingo. Don't get too serious about it. Stick with one type of lingo. I like to just say horizontal compression equaling 1/2, meaning I'm half of what I used to be. The next video, we'll get on to an expansion. So once again, always substituting the opposite operation for the variable. If I have the equation y equals x squared and I want to do a horizontal compression of 1/2, I would substitute 2x in for x. If I wanted to do a horizontal expansion of 2, I would substitute 1/2 x in for x. We will see all sorts of examples of these in the notes. I'm not always going to be doing theory. Just wanted to get our heads in the right game for the first chapter and onto a vertical transformation. All right, not again. The last one, I promise. Y equals x squared. This time we're going to take the point 1, 1. It was very boring. 2, 4. Let's change it up a little bit. Now let's take the function y equals 2x squared. Not open bracket 2x close bracket squared, but simply 2x squared. So what has happened to get this 2 here? Again, remember the plus 2 that we were speaking about off to the, the minus 2 off to the right, and how it got there by substituting y plus 2 and then subtracting 2 from both sides? Well, I'm wondering where this 2 came from. Well, I had the function y equals x squared, and I know that the only thing I'm allowed to do is substitute the opposite operation for the variable, and the more people that figure out how simple math is when there's just one simple method to do a whole bunch of things rather than learn 8 or 10 different ways to do the same thing, and then do little simple lazy things or follow teachers by just slipping 2's in front of things. In the future, when we get more familiar with the material, absolutely, we're going to do little things that skip steps. But until then, I'm going to do proper math. So, how did that 2 get there? Well, I must have substituted something for something. So, I'm going to take y, and I'm going to substitute 1/2 y in for y. I'm going to take y, and I'm going to turn it into 1/2 y. Now, what would that do? Well, we've learned for the last 3 videos that we always substitute the opposite operation for the variable. So this looks very much like I put 1/2 y in for y, so it looks like the opposite would be timesing the y values by 2. So, again, we have the point 1, and we're wondering what the y value is. So, if y is now 1/2 y equals x squared, and I want to solve for the y value, the first thing I'm going to do is I'm going to times both sides by 2. Now remember in the last 2 videos ago, I said I was never going to subtract 2 from both sides of the equation, or if I ever was, I was just going to say it and everyone would just see or just find out where it showed up. Well, I'm sorry, I fibbed. I did it one more time. So in the future, I'm not going to say I'm going to times both sides by 2. I'm just going to cross off. Excuse me. I'm just going to times both sides by 2 by crossing off the 2 and putting it where it belongs. And that is where that 2 came from. Never lazily just putting -2's off to the right of things for no logical reason at all, or ever just tucking in a little 2, no matter how many of your teachers just put a little 2 in there. Put your hand up and say, "Sorry, Mrs., can you please do the proper method and substitute the opposite operation for the variable and then multiply both sides of the equation? It would be a lot more helpful for me." They may not like you for that. Don't ever be too mean to teachers. We'll go into all sorts of different ways to get better marks in the future, and you just want to be just interesting enough, but not annoying. So that is where the 2 came from. So we are asking ourselves, what is y? Well, if we have the equation y is equal to 2x squared, and I have an x value of 1, I can simply substitute 1 in for x, and 1 squared bed mass is 1 times 2 is y equals 2. So what's happened? Well, let's take the graph and let's put the point 1, 1 on the graph, the one that we started on this video. And now we have a new point on the graph when we just figured out the y value to be 2. So we have the point 1, 2, which is on the graph right here, 1, 2. And what happened to this point? Well, it was a vertical expansion by a factor of 2, multiplying all the y values by 2. So just as we planned, we substituted 1/2 y in for y, and substituting the opposite operation for the variable, substituting 1/2 y in for y, would multiply all the y values by 2, taking y values of 1 and multiplying them all to be 2. Feel free to take a look at the graph on the left in the notes and see the vertical expansion of 2, multiplying all the y values on the graph by 2, each and every point. Again, one more time, substitute the opposite operation for the variable and you'll memorize one method, not a whole bunch of different ones. If a teacher is going to do a lazy little thing, make sure that every time if you see that 2 in front, or if you see that -2 off to the right of the equation, think, where did that come from? Here we substituted y plus 2 in for y, doing the opposite operation, making the y values going down 2, subtracting 2 from all the y values. Here, substituting 1/2 y in for y, doing the opposite operation, multiplying all the y values by 2, a vertical expansion by a factor of 2. And that's the theory. Again, we're not going to do very much theory. There's a little bit more theory in the finance section because I have a finance major from solder at UBC. I'm going to be doing a lot of examples, mostly word problems with analogies with respect to business, but then again, lots of physics, etc. So we are now on to the notes. Again, we'll do an introductory video in the future, but for now, read the notes, try the homework. If you can't do the homework, watch the videos that are associated directly with the notes. Then try the homework again. And remember, it's much more introductory stuff. It's much more do it before class. Be ahead of the game. Be able to use the class time to actually ask really good questions, being prepared. You will spend a lot less time in the future getting ahead of studying and using class more effectively than being behind and then studying after the fact without being able to ask the teacher or your peers those questions.